So I want to walk you through how you actually would end up doing the BLAST search, simply because it's not too difficult if you follow the directions. So if you go to calendar, obviously I have a lot of junk up here and I need to update some more things. But how to BLAST, if you click on that, there's nothing there. I was supposed to show you in class, but clearly we didn't get there. So BLAST, BLAST Labs, click. So you get this. The part I'm going to encourage you to do, I'm not going to do it for you, is I really encourage that you do this part right here, simply because it's a nice way to walk through. It tells you what BLAST stands for, so Basic Local Alignment Search Tool. I don't remember that, don't worry about it. There are other things in here, I just don't remember what they are, so it doesn't matter to me. So 2, let's run a search. I'm going to do one where I know it's not going to work and one where it will work. So you click, you get this screen. Up here at the top where it says gene, so we're looking for a gene, we can put in a name. So I'm going to look for human polydactyly. Human polydactyly is when you happen to have multiple digits, meaning you have more than 4 fingers and a thumb on a hand. So let's see what we get. So it's going to search. And this is what I got, which is a lot of information. Since I'm looking at this, actually I know what some of these things are. Some of these things I definitely don't know what they are. But if I were thinking like you, I would say, oh, I'm going to look for polydactyly. Oh, I know, polydactyly. It says polydactyly right there. And it says Homo sapiens, human. Sweet, I'm going to click on Papa 4. Papa in 0 period is very happy seeing this. And this shows up. What I need to find is a reference sequence. And if we look here, I don't have anything. Gene type, it says unknown. This bit here where it says lineage, this is telling you the domain, and then we have animal. Then we were talking about, oh, what type of animal you are. Then we have a chordate, and then which is a phylum, and blah, 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 until eventually you get to genus of Homo. So needless to say, we can go through a whole lot of junk here explaining where we are, but we don't have a gene. What that tells me is, I chose poorly, let's try again. So I'm going to try instead for human, and this is a gene I just happen to know exists, or at least an enzyme I know exists because I've gone through AP Bio once or twice, and if I didn't, I could open up the white biology books that are on the side of the room that say Freeman Biology, or I could open up the Campbell Biology. If I open them up and look for anything that has a protein, one of those proteins I could find is hexose kinase, which is actually among the first enzymes used in glycolysis. So if I search for that, hey, I have glucokinase or hexose kinase for humans. So if I click on that one, obviously I have a whole bunch of other choices, but I'm going to pick on that one. And I get a whole bunch of information, same lineage. But now I get more information than I thought I would get before. If I keep scrolling down, eventually I'm going to have something that says reference sequences, which is right here, NCBI reference sequences. What I want to find is a reference sequence related to a protein. I want to know a protein. If I click here where it says genomic, that's going to give me a genome. It's going to give me a huge chunk of DNA that may or may not be useful. Odds are it won't be useful. So if I click down here where it says mRNA and proteins, right here it says NM, then 000162.3. If I click on that, I'm taken to this screen that tells me where this stuff came from. There's the sequence right there. But if I click on where it says FASTA, not faster, but FASTA, I'm given the sequence of DNA, A's, T's, C's, and G's for glucose kinase. If I do not have A's, T's, C's, and G's in this, you have something other than DNA. If you have M's and Q's and R's and S's and W's and Y's, you actually have a protein sequence. So make sure that you're looking at a DNA sequence. So if I were to highlight all of this and copy it, what I could then do is do a BLAST search. So that would be E down here. So now we have a BLAST, and in particular, I'm doing a nucleotide BLAST. I know that because I have DNA. What I could then do is enter that in, And I want it to look for something other than a human and other than a mouse, so other. If I felt like it, make sure it says nucleotide collection, I could name something else like E. coli, but let's not do that right now. Let's just see what it does. Blast. So it's going to run through and it's going to think, and then you're going to get a hit result. Let me tell you how you interpret all of this. So we have all sorts of information listed here. Each of these things is a different organism, like, let's see, do I know any? Bison. That's going to be a bison. That one's pretty obvious. Do I know any other ones? Gorilla is obviously a mainland gorilla, or a lowland gorilla, as it were. Trogliodes, that would be a chimpanzee. So some of these are big giveaways as to what they are, and others aren't. When we look, like it says Homo sapiens right here, there's this thing called an e-value, which is how far off is the value, how much of a mistake is there. Our goal is to have this thing near 0, because that tells you that it's really closely related. And if you look, going down through what are all these things, so equus, this is some type of horse or a mule or a ass or something like that, ass meaning donkey, if you're not sure. They're all zeros, meaning, holy cow, this is a near perfect match. The closer you get to 0, the better the match turns out to be. You could even, if you felt like it, you could get a tree that will show you, based upon what you put in, well, here's how you can connect everything together. And you can mouse over and see what things turn out to be and what have you. And over here off to the side, they even tell you, hey, here's what we're looking at. But I'm just curious. I'm going to go back. I'm going to put this in for E. coli, Escherichia coli. Escherichia coli. I'm going to look for that one. Now let's see how it does the search. It's thinking still. It's thinking still. They didn't happen to have anything that turned out to match, and there could be a whole bunch of reasons why. What that would tell me is, look at something else. Try again. So that's how you do a BLAST search, and then you just go back, and let's start with something new. Not at nucleotide, but we want to go to gene. Then I can pick something else and look it up. So I can do this over and over and over again as much as you want, but you have to do things in the correct order. So when you do a nucleotide search, you type in whatever you want. It helps if you type in the name of the organism. You pick the gene that seems to match, or at least the description that matches. You're going to go down to where it says reference sequences, NCBI reference sequences. Go to mRNA and protein. Click the first thing that you see. Should be a bunch of weird letters. Then you click on FASTA, which will give you the sequence. You copy and paste the sequence into BLAST. You pick a nucleotide BLAST. You put in your sequence. You want to make sure that it looks for other. You don't necessarily need to put in an organism. Then you say search. When you do the search, you look for small e-values. Small e-values mean, hey, this thing turns out to work, meaning there's a good match between the DNA. The larger the e-value, the closer you get to a 1, the more the two don't turn out to match in any way, shape, or form. And that's all you need to do for a BLAST search. Good luck tomorrow.